Welcome, my friends. Let's take a look at this problem. 5, 2 is a point on the terminal side of theta. We are asked to find the exact values of all 6 trigonometric functions. Now note that the point 5, 2 is not on the unit circle. Nevertheless, we can still think of a circle to help us envision the problem. So here we have a circle. The point 5, 2 would be somewhere over here in the first quadrant. We can envision a radius drawn from the center out to the circle, which will create some angle theta. If we draw a straight line down to the x-axis, we have created a right triangle. Let's work with this right triangle on the side. We know that the point up here is the point 5, 2, and the point down here is 0, 0. The base of the triangle is the x-coordinate, which is just 5, and the height is the y-coordinate, which is just 2. In order to find all 6 trigonometric functions, we're going to have to know the hypotenuse. So let's solve for that using the Pythagorean theorem. We can call the hypotenuse c. Therefore, we will have 5 squared plus 2 squared is equal to c squared. 5 squared is 25, and 2 squared is 4. So 25 plus 4 is equal to 29. So we have 29 is equal to c squared. That means that c is equal to the square root of 29. So we can place that number onto our triangle. Now that we have solved for all the sides of our triangle, we are ready to find the 6 trigonometric functions. We know that sine of theta is equal to opposite over hypotenuse, or 2 over the square root of 29. We know that cosine is equal to adjacent over hypotenuse, or 5 over the square root of 29. In both cases, we will want to rationalize the denominator, so we will multiply both of our answers by the square root of 29 over itself. For sine, we will get 2 square root of 29 over 29, and for cosine, we will get 5 square root of 29 over 29. Next, let's find cosecant. Cosecant is the reciprocal of sine, and sine is opposite over hypotenuse, so cosecant must be hypotenuse over opposite, or the square root of 29 over 2. Next, let's find secant. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, or 5 over the square root of 29, so secant must be the square root of 29 over 5, or hypotenuse over adjacent. Tangent is opposite over adjacent, or 2 over 5. And cotangent is the reciprocal, or adjacent over opposite, which is just 5 over 2. At this point, we have found the exact values of all 6 trigonometric functions. Let's try another problem. 5, 6 is a point on the terminal side of theta. We want to find the exact values of all 6 trig functions. Let's take a look at the circle. 5, 6 puts us somewhere in quadrant 4. So just like last time, we could draw a radius from the center of the circle to our point, and then a vertical line all the way up to the x-axis, and that will create our triangle. Note that the angle theta is technically the angle from the positive x-axis all the way around until we hit our radius right here. It's a little bit nicer to think of the angle as the interior angle on our triangle, and as long as we correct for the sign on our trig functions, knowing that we are in quadrant 4, this will work out just fine. We can work with this triangle on the side. We have an x-coordinate of 5, which is the base of our triangle, and we have a y-coordinate of -6, which is the height of our triangle. It might seem a little bit odd to have the height of a triangle be -6, but that is just to represent that we are in quadrant 4, where the y-coordinate is negative. Again, we will have to solve for c, the hypotenuse of the triangle. We can do this using the Pythagorean theorem. We have 5 squared plus -6 squared is equal to c squared. This will be 25 plus 36 is equal to c squared, and 25 plus 36 is equal to 61. If you take the square root of both sides, you will get that c is equal to the square root of 61, which is the hypotenuse of our triangle. From here, finding the 6 trigonometric functions is very similar to the way we did it in the previous problem, so I encourage you to pause the video and see if you can find them yourself. Okay, sine of theta is equal to opposite over hypotenuse, or -6 over the square root of 61. Again, we will get a square root in the denominator. So sine of theta is -6 over the square root of 61. We can rationalize by multiplying by the square root of 61 over itself, and we will be left with -6 times the square root of 61 over 61. Cosine of theta is adjacent over hypotenuse, or 5 over the square root of 61. Once again, we will have to rationalize that denominator, so we will have to multiply by the square root of 61 over itself. We will be left with 5 times the square root of 61 over 61. Cosecant of theta is just the reciprocal of sine. And if I look at this expression for sine, we would just have the reciprocal, which is negative square root of 61 over 6. Or you could think of it as hypotenuse over opposite, which would just be square root of 61 divided by negative 6, which is exactly what we have here. Secant of theta is the reciprocal of cosine, so perhaps I would take the reciprocal of this expression right here, and I would have the square root of 61 over 5, or I could take hypotenuse over adjacent, which is the square root of 61 over 5, the exact same answer. Tangent, on the other hand, is opposite over adjacent, or negative 6 over 5, and cotangent will be the reciprocal, or negative 5 over 6. Let's take a look at a slightly different problem. Let the angle theta be in quadrant 2, and let sine of theta equal 15 over 17. We are asked to find the values of the 6 trigonometric functions. Let's draw a circle. Now, it was very important for them to tell us that we were in quadrant 2. We know that sine is positive, meaning that we would be either in quadrant 1 or quadrant 2. We need some kind of information to narrow us down to which quadrant we're in, and they tell us specifically that we are in quadrant 2. So we can draw a triangle in quadrant 2. To draw your triangle, always draw a radius from the center out to some point on the circle. It doesn't really matter exactly where it is. And then always draw a vertical line back down to the horizontal axis. Now note that just like in the last problem, theta is technically the obtuse angle from the positive x-axis all the way up to the radius that you drew, but it's a little bit more convenient to think of theta as the interior angle of the triangle. Everything will work out as long as you consider which quadrant you're in when assigning the side lengths of the triangle. We are told that sine of theta is equal to 15 over 17, meaning the opposite side is 15 and the hypotenuse is 17. We can work with this triangle on the side. We need to find the side length of b, which we can find using the Pythagorean theorem. We have 15 squared plus b squared is equal to 17 squared. 15 squared is 225, and 17 squared is 289. So we have 225 plus b squared is equal to 289. Subtracting 225 from both sides, we get that b squared is equal to 64. If we take the square root of both sides, we will get that b is equal to plus or minus 8. In the past, when we've used the Pythagorean theorem, we've always disregarded the negative answer. In an example like this, where we have an angle that is somewhere other than the first quadrant of the unit circle, sometimes that negative answer will be relevant, and this is one of those cases. So our point on the unit circle would have a negative x-coordinate, which means that we have to represent that on the base of our triangle. So we don't need positive 8, we actually need negative 8. From here, we can solve for the 6 trigonometric functions. Sine of theta is opposite over hypotenuse, or 15 over 17. This was also already given in the problem. Cosine of theta is adjacent over hypotenuse, or negative 8 over 17. Tangent is opposite over adjacent, or 15 over negative 8, or just negative 15 over 8. Cosecant is the reciprocal of sine, or 17 over 15, and secant is the reciprocal of cosine, or negative 17 over 8. Finally, cotangent is the reciprocal of tangent, or negative 8 over 15. Let's try another problem. Let the angle theta be an angle in quadrant 3 such that cosecant of theta is equal to negative 4. We are again asked to find all 6 trigonometric functions. Recall that cosecant is just the reciprocal of sine, so cosecant and sine are negative in either quadrant 3 or quadrant 4. We are told specifically that we are in quadrant 3, so let's draw a triangle in quadrant 3. Always draw your triangle so that you have a radius from the center to some point on the circle, and then draw a vertical line up to the x-axis. Since cosecant of theta is negative 4, and sine is the reciprocal of cosecant, that means that sine of theta must be equal to negative 1 over 4. That means that our opposite side must be negative 1, and our hypotenuse must be 4. We know that the opposite side has the negative sign because we are below the x-axis in quadrant 3, so that our height must be negative. We can work with this triangle on the side. We can solve for a using the Pythagorean theorem. A squared plus negative 1 squared is equal to the hypotenuse squared of 4 squared. We get a squared plus 1 is equal to 16. Subtracting 1 from both sides, we get a squared is equal to 15. We take the square root of both sides to get a is equal to plus or minus the square root of 15. Now a is the base of the triangle, which is going to represent our x-coordinate. Since we are in quadrant 3, our x-coordinate must be negative, because we are to the left of the y-axis, so we must take the negative square root. so a is equal to negative square root of 15. Let's find the 6 trigonometric functions. We already know that cosecant of theta is equal to negative 4, and earlier we solved for sine by reciprocating. Cosine is adjacent over hypotenuse, or negative square root of 15 over 4. Secant is just the reciprocal of this, which is 4 over the negative square root of 15. We can rationalize the denominator by multiplying by the square root of 15 over itself to get negative 4 square root of 15 over 15. Tangent is opposite over adjacent, or negative 1 divided by negative square root of 15. We can rationalize the denominator by multiplying by the square root of 15 over itself to get square root of 15 over 15, and also note that the negatives would cancel each other. Cotangent would be the reciprocal of tangent, so maybe the easiest thing is to reciprocate this value right here. We would have negative square root of 15 over negative 1, the negatives would cancel, and we would just have the square root of 15. Let's try one final problem. Suppose that secant of theta is equal to 13 over 12, and tangent of theta is less than 0. Now, why are they telling us that tangent is less than 0? Well, that is to help us to narrow down which quadrant that we are in. If we know that secant of theta is positive, then cosine would also be positive, and cosine is positive in either quadrant 1 or quadrant 4, where our x-coordinate would be positive. But if tangent is less than 0, that means our ratio of sine to cosine, or y to x, must be negative, or that our x and y coordinates would have opposite signs. So where on the circle do our x and y coordinates have opposite signs? Well, that would either be in quadrant 2, where y would be positive and x would be negative, or in quadrant 4, where y would be negative and x would be positive. So the secant information is telling us we are either in quadrant 1 or quadrant 4, because secant is positive, and the tangent information is telling us we are either in quadrant 1 or quadrant 4. The quadrant in common is quadrant 4, so theta must be in quadrant 4. So let's draw a triangle in quadrant 4. Always draw your triangle so that you have a radius from the center to some point in that quadrant, and then draw a vertical line up to the x-axis. We are told that secant of theta is 13 over 12, which means that cosine of theta must be the reciprocal, or 12 over 13. That means adjacent over hypotenuse must be 12 over 13. Let's work with this triangle on the side. We can use the Pythagorean theorem to solve for the missing side a. A squared plus 12 squared is equal to 13 squared. 12 squared is 144, and 13 squared is 169, so we have a squared plus 144 is equal to 169. Subtracting 144 from both sides, we get that a squared is equal to 25. Taking the square root of both sides, we get that a is equal to plus or minus 5. So think to yourself for a second, which of those do we need? Positive 5 or negative 5? Since we are in quadrant 4, a must be negative, because we are below the x-axis. So a is equal to negative 5. Let's find the 6 trigonometric ratios. We already know secant is 13 over 12, which means that cosine must be the reciprocal, or 12 over 13. Sine is opposite over hypotenuse, or negative 5 over 13. Cosecant is the reciprocal of that, or negative 13 over 5. Tangent is opposite over adjacent, or negative 5 over 12, and cotangent would be the reciprocal, or negative 12 over 5. Alright, my friends, that wraps up this video of finding trigonometric functions given information about an angle.